Hello, my name is Chantal Redman.
And I'm Thomas Renwick. We are reviewing Choice Magazine's article, Competition Issues in the Seed Industry and the Role of Intellectual Property, written by Giancarlo Maschini.
Seeds are the starting point of all plants. Over time, as technology has progressed, people have been researching and practicing techniques to improve the seeds that feed our world. Since the beginning, farmers have been selecting seeds that provide them with the best crops possible. As technology has improved, so has the quality of these seeds. Farmers select a crop based on its genetics to provide them with the best yield possible so they can provide the world with the food it needs. Modern seed development research is highly advanced. Researchers are able to identify genes that they transfer to the seeds grown today. The genes chosen by researchers are for desired traits. These traits include better nutritional characteristics and tolerance to the environment in which they live. The goal of GM traits is to produce plants that are healthier, more resilient, and capable of producing greater yields. Once the genes are selected, they are implanted into the seed using a technique called a horizontal gene transfer. This technique was developed by Mark van Montague of the University of Ghent. The technique uses agrobacterium, which carries the genes to the seeds where they bind with the plant's DNA. The development of a biotech crop is a lengthy process, however, it produces significant benefits to the farmer. Biotech crops have resulted in improved farms which help to meet the rising need for food as the world's population grows. Biotech crops can also enhance the quality of sustainable farming practices such as no-till.
The beginning of patent law dates back to Britain in the 17th century. It has since spread internationally and widened in scope, culminating into the International World Intellectual Property Organization in 1967, which is an agency of the United Nations. Historically, patents were not awarded on living things, but this was changed in 1980. We will look in more detail at the implementation process and the different approaches that the United States and Canadian systems have taken towards patenting genetically modified life. In America, patent law was reinterpreted after the United States Supreme Court ruled in the Diamond v. Chakrabarty case, in which it was decided that genetically modified bacteria designed to break down oil could be patented. This opened the door for biotech companies to develop new seed genetics and have them protected by strong patent laws. In 1982, Canada followed the US's lead in allowing a patent for microbial culture systems composed of different forms of yeast. This was the first case that life was patented in Canada. However, in 2002, the Supreme Court of Canada set a precedent in that higher life forms could not be patented in Canada. This was decided in the Harvard College v. Canada Commissioner of Patents case, where Harvard University attempted to patent a genetically modified mouse that was highly susceptible to acquiring cancer. Higher life forms constitute complex life, such as plants and vertebrates, which is in comparison to so-called lower life forms, which include single cells, cell clusters, and line cell organisms. In order to incentivize industry to invest in seed development within Canada, the government introduced the Plant Breeders' Rights Act, implemented in August 1990. Under this act, any plant, excluding algae, fungi, and bacteria, may be protected by plant breeders' rights as long as it satisfies four key characteristics. Firstly, the plant must be new, not having been commercialized more than a year within the country. Secondly, it is distinct from all other known varieties by one or more important botanical characteristics. Thirdly, there must be uniform characteristics from plant to plant within the variety. And lastly, the plant must be stable in that its characteristics remain fixed from generation to generation or through reproduction cycles.
Intellectual property rights and antitrust laws both aim to increase efficiency and improve the performance of a market economy. However, when exclusive control of innovation is obtained, it creates a market power. Innovation plays a key role in the agriculture industry. It drives productivity and environmental sustainability. Therefore, it is desirable to support and protect intellectual property rights. IPRs are property rights defined over intangible assets that are the result of human incentiveness and creativity. IPRs need to be protected to encourage investments in research and development so that the plant science industry can maintain a strong innovative base. This is done through patents. A patent is a form of an IPR. It gives the inventor the sole right to exclude others from selling, making, or using the innovation for a limited time period. Patent protection on seed production has increased the profitable research and development investments in the seed industry. Without IPRs, people lack the incentive to innovate due to the cost and the free rider problem that the market would provide, but the market struggles to handle IPRs properly because knowledge is a public good. Public goods are non-rival and non-excludable. IPRs provide the legal means of affecting the excludability attributes of the public good. The inventor bears the cost of the innovation, however, everyone may benefit from the innovation and therefore people have the incentive to free ride. Free riders take advantage of competing firms and individuals by copying new ideas without reimbursing the original creator, effectively destroying the incentive to innovate. This could result in a serious market failure. The objective of IPRs is to increase welfare by promoting innovation. However, in order to maximize social optimization within markets, IPR laws are balanced with the use of antitrust laws.
Antitrust policy, or competition laws, are designed to promote fair competition amongst firms in industries in order to achieve market optimization for the benefit of society. If a single firm or small group of firms have control over the market, they are able to lower the quantity of production and therefore raise the price of a product, which lowers the benefit to society. Some anti-competition actions include collusion, predatory pricing, dividing territory, and, relevant to our topic, monopolization. Intellectual property rights is a type of socially sanctioned monopoly. Society deems a specific monopoly as tolerable because as firms and individuals are driven for profit, they will create new inventions in order to access a temporarily protected monopoly in which there is no competition, therefore higher profits. After the patent ends, competition resumes within the product's market, and so we achieve social optimization along with better products.
Farmers will incur increased expected yields as a result of GM traits. However, this will come with a cost. Farmers will have higher seed prices due to the cost of research and development carried out by seed and agrochemical companies. This is dependent on the level of innovation and whether or not the industry is competitive. In 2001, the U.S. Department of Agriculture started to separate prices for biotech and non-biotech seed varieties. Farmers pay a price markup on GM seeds for their developed traits such as herbicide and insect-resistant traits. Monsanto started out charging a technology fee to the growers. However, they replaced this with a more flexible way of pricing the product. They now use a royalty system paid by the seed companies licensed to use the traits. Licensing of GM traits is an essential component of current industry practices. According to Shin in 2012, the GM seed industry has been growing steadily since its commercial introduction in 1996. In 2011, GM crops reached 7% of the total cultivated land area of Earth, which was worth $13.3 billion US. GM crops are an economically important aspect of the agricultural industry, which is only growing each year. There is potential that when the patents of these GM traits expire, companies will set out to provide the seed industry with generic versions of the trait. Once a patent ends, a product becomes generic and any company can manufacture and sell it.
Monsanto's single-gene Roundup-Ready soybean plant became generic in 2014. This allowed producers to keep and own the seed for the first time, as well as other seed companies to act as seed growers and sellers for the market. This drastically lowered the price of the seed as well as increased its popularity for soybean growers. The seed biotech industry has as a result continued to develop new GM seeds. Monsanto is now offering Roundup Ready 2 genetic crops that promise improved performance. Technological progression is evident due to the motivation to innovate that is created by intellectual property rights. As market power consolidates under fewer and fewer firms in the seed biotech industry, it is important to ensure that competition stays high in order to maximize societal benefit as well as technological progression. Referring to Table 1, it becomes clear that market power is consolidating under several large firms. Further proof of consolidated market power, as quoted by Giancarlo, in regards to Monsanto, the largest biotech GM company, states, Monsanto invested early and decisively in agriculture biotechnology, leading to the release of GM varieties, first commercialized in 1996. Its early advantage and continued commitment to this R&D path has resulted in a dominant position in the GM traits found in commercialized varieties of soybeans, cotton, and corn. This is illustrated in Table 1, which is based on data made available by Monsanto to its investors, but present values in this table are calculated based on USDA planted acres. Note that the share of U.S. grown crops containing one or more Monsanto traits has increased steadily over time. In 2009, this share amounted to 81.1% in corn, 94.5% in soybeans, and 78.9% in cotton. We can see the balance has been challenging to establish between incentivizing industry to innovate and the protection against the negative effects of monopolies. There are three main stakeholder groups interested in the GM industry: the public, producers, and private firms, all of whom have different motivations. The public desires cheaper, safer, and higher quality food. The producers are looking for more reliable crops that provide good profit margins and consistent performance. Farmers desire cheaper seeds, sometimes at the cost of performance. As quoted from VideGr23, some growers are going to choose the public variety because it is cheaper, even if the private variety is better suited for their land type and has potential to increase their yields and social surplus. Private firms are motivated to enlarge market control and gain larger profits for its owners. This causes the price of GM seed to be high relative to non-patented GM seeds. As stated by the Choices article, simply comparing the last available year, 2008, to pre-GM year of 1995, we see that the total price increased over this period is 139% for biotech corn, 49% for non-biotech corn, 199% for biotech soybeans, and 96% for non-biotech soybeans. This is the defining issue at the heart of competition issues in the seed biotech industry. Biotech firms are using monopolies to increase the firm's producer surplus at the cost of consumer surplus, and market deadweight loss is created in the market. In other words, the price of food goes up as the quantity of consumption goes down, and the trade-off is that society attains the highly advanced seed technology. Informed policymakers must take all of these desires into account when making new policy.
Thank you for listening to our presentation and to Professor Bullock for allowing us to use her research while completing this review.